Hello, testing. No sound. Hello, everybody. We're going to start in a minute. I need to know if this is streaming. Okay, good. Sounds like it's working. Okay. So I have prepared a slide, and I'm going to go over that, but I can see the chat screen here on my phone. So if you have any comment, please put it on the chat in YouTube, and I'll be able to answer it immediately. This is a one-way webinar. You are unfortunately in YouTube not easy to give you the chance to talk interactively, so we have to use the chat for questions. But the idea is that the YouTube platform is very practical for making the webinar available for people to watch it on their own time, and this is the nature of the course. Everybody logs in at their own time, so we have to do things this way. So I have prepared this. I wanted to give an overview of the dog breed classifier project, and hopefully have a bit of discussion on this, because it's an important project. It's the first project that it really uses the tools for deep learning, and you get to see the power of a neural network dealing with data that you cannot really process in any other way. So I have structured the information in kind of conceptual layers, starting from the very bottom, how to set up the infrastructure for deep learning, and second, how to load image data. We're talking about a lot of volume of data, so you need some special code to do it. Normally this is referred to as ETL in industry, and is a pattern for export, transform, and load, extract, transform, and load. So essentially everything that has to do with data in the data science cycle, and it has less to do with science, but it's a really essential part when you have to do an application. In the third layer, I just go over the different CNN layers that we're going to apply, and fine-tuning hyperparameters, or how to change them to try to extract the best accuracy. In the last layer, I have tried to put some tips on transfer learning, which is mostly in every practical project what we end up doing, unless you work for a really big company or you have a lot of data for some reason. Okay, so let's review the first part, which is the how to set up the environments. We have seen in the first project in this nano degree how to set up the Python environment in your local laptop, and how to use hopefully you understood how to use Conda and set up Anaconda and create Conda environments and put all your setups in environments. It's very useful to work with environments, especially to avoid problems with versions. Also, to when you are going to share the project, to share the requirements of the environment is very easy. So in this case, you already saw how to use the Python environment for deep learning. There are if you use only Python, you have to create all the backpropagation yourself to train the neural network, and in general that is not super optimized, of course, but you can still use it for projects with what we call structured data. Structured data is just not a very strict definition, but essentially is when your data comes already structured nicely in columns and rows. So each column has a particular meaning. One of them is the date, the other one is the number of bikes rented, and all those features have very clear meaning, and you don't have to extract anything. You just use the features as they come. In this case, we are in this second project, we are using other type of data. We are trying to essentially learn computer vision problems, or in the next project we're going to work with language problems. And for those, here is really where artificial intelligence starts. And for that kind of data, you of course you have noticed that in an image, your data doesn't have any column or row. Is not doesn't have a different meaning. Each column and row is just a position in an image, and it has the same meaning as the next pixel. It's just a pixel. It's the intensity of light. So in this case, we use deep learning for extracting information from that sea of pixels. And we consider that unstructured in the sense that it doesn't have a particular meaning. Every pixel and their neighbors are just the same in terms of semantically. And so we use deep learning to recognize objects. So once we have objects, we can start to apply classifiers, or basically we can start making decisions. Do we recognize a person here or recognize a dog? So this is what this project is teaching you. And in this case, we're going to I have two setups that we can use for deep learning, and one is in the laptop, and you can set up your PyTorch environment in the laptop. If you have a CPU, it's very simple. I use Anaconda, as I recommend to use the Anaconda distribution, because they already resolve for you a lot of the incompatibilities between the different libraries. And Python is all about using libraries. So do install Anaconda, and then when you create an environment with this conda create command, you can specify what you want there, and everything will be ready for you. And then you can get rid of it if it doesn't work very easily, and nothing is left in your machine. So if you have a laptop with a GPU, I know that there are certain brands that are creating laptops with Linux, and they are working very well with GPUs. They're a little bit pricey, but they do the job for these kind of things. So the only thing that you have to change is that you have to specify the version of the CUDA toolkit when you install PyTorch. So the same, you can use the same install. It's just that on top of it you install the CUDA toolkit. And once you have everything installed in an environment, to use it, you have to activate it first, and then you just launch the Jupyter Notebook from inside the environment. That way it loads all the libraries. The other way to set things up is using an AWS instance, and in this case you have to go through the instructions that are in lesson 2 cloud computing, for example, and the page 6 where it says log into the instance. You have some idea there of how to set up the instance. So one of the things that I found out is that instances in Amazon, they already come pre-configured with their own CUDA toolkit and everything, and they tend to not use Anaconda natively. They just install it in the system. So what we have to do is don't use Anaconda in the AWS instance. I haven't even tested them, but I figure that it's going to mess up things, because all the CUDA configuration in the machine has been done directly on the system, the Python install on the system. So one of the things that I understood is that we're using Python 3, so we need to install things with PIP. But PIP3 is the installer for Python 3. If we install with PIP plain, you might end up installing it in Python 2. So make sure that things gets installed for Python 3. So once you have the instance set up as per the instructions in page 6, you will find that the PyTorch version installed in the instance is very old, so you have to update it. And there are because the the libraries are installed in the system, you have to use supervisor permissions. So that is what the Linux command sudo does for you. So one way to go about this, the way that I have shown here, is to give yourself permissions. You are logging in with the user Ubuntu. This is the default user in the instance. You can change it, of course, but here I show you the path where the libraries are installed. User local bin. You have to give them permission to the user Ubuntu to update this path. So once you have permission, you can use pip3 install and upgrade your PyTorch version. This URL, it comes from the PyTorch page, and this is where they have the particular libraries for the Amazon instance, which is a Linux x86-64. So this is going to install PyTorch 1.01, and with that you can use Torch Vision. So now you can actually install Torch Vision with more or less the same commands. So first you are going to give yourself permission to update the libraries in Python 3.5 and then run pip3 install Torch Vision. There is another way to do this in Linux, and it's essentially sudo the pip3 command. So if you sudo, don't do this at the beginning and just use sudo in the pip3 command, you are going to be installing it as an administrator, and it will work. But I just try this way. Okay, I hope you get your AWS instance set up. Just remember to shut it down every time that you finish working. The instance has to be stopped, not shut down, but essentially you have to go to the AWS page and stop the instance, because otherwise it keeps charging money to your account. So the next level in this process, in your pipeline, once you have set up the Torch Vision libraries, is how to load the data. I have shown here two transforms for Torch Vision, that one for train and one for test. Let's take a look at the train transform. The first thing I do is resize every image to a particular size. So I resizing them to squares of 255 width and height. So this is done because your images might come in different sizes. You might be taking pictures that give you images of thousands by thousands, and for the kind of work that we are doing, we are with a size of 200-300 pixels, we have enough information. So we resize them to 255, and we also take a center crop of 224. So that means that if your image was rectangular or was not perfectly square, you are going to convert it in a square. So all the images will have to have the same shape, the same number of pixels to be processed by your neural network. So with these two transformations, what we are doing is more or less normalizing the sizes of the images, because we know that they come with different resolutions and different shapes. After that, there is a little bit of data augmentation the next two transforms. So training data is going to be rotated randomly up to 30 degrees, and it will be randomly also applied a horizontal flip, or essentially looking at the image in the mirror. So you want your data to have all these variations, so when you train your network learns to be insensitive to these variations. Essentially, it will not pay attention to the angle, or if the dog is looking towards the left or towards the right. The next transforms are just moving the image into a tensor shape, tensor class, and the final one is normalizing the image. Now we know these images are coming with values between 0 and 1. So we have this normalization that basically the images have 3 channels, red, green, and blue, and each one of these numbers is the mean value for each one of the channels overall the data set. Not the dog data set that you are using, but the standard computer vision data set that is used for training the pre-trained models, which is the ImageNet data set. It has millions of images, and they have compute these normalization parameters. The first row is the means, and the second row is the standard variation for each one of the channels. So we use that and for all kind of images that are similar to the ones in ImageNet. It's a very wide use data set, so it has all sorts of images, so it's very generic. Of course, if you were using this to do image recognition for any particular application, and you have a data set for, let's say, medical images, you will have to recompute this for your particular data set to be more accurate. I mean, you don't have to. You probably would like to try to see if you can get more accuracy doing that. The test transform is the transforms applied for the new images that you are going to. Well, in this case, we're using for testing, but in a real application, this would be the images that come from users. So you don't know what comes there, so you definitely have to resize it and center crop them. So you normalize the size, and then move it to tensor, and then normalize the value of the pixels in the images. So after normalizations, what you will have is essentially values in each pixel that go from that are distributed around 0. I suspect normally distributed because of the number of pixels. So these numbers will be distributed around 0. It will go from -1 to 1 approximately. Okay. The last picture I think I'm jumping here. Okay, well, this is it. So so I don't have don't have a slide. I don't seem to have a slide for the Scratch data set. So I'm going to show you directly in a project the kind of network that you can use. So this is an example of a network that I put together with batch normalization. So we haven't talked much about batch normalization in the lessons, but essentially when you have many layers in a neural network, the most effective normalization in between convolutional layers is batch norm. So this is a way to use batch norm. You essentially want to normalize before using it into the next layer. So at the output of the first convolutional network, I batch normalize, and I have to pass the number of units. So essentially the number of channels that are normalized. Normalization is done by channel, so there is no normalization between channels. Essentially, you're making sure the values of the activations in one channel, in one feature map, is normalized, but the other feature map doesn't affect your normalization value. So you have to calculate it once for every channel. So this is what it looks like when you do the forward pass. So it's essentially a bunch of layers where I'm doing the convolutional neural network, then the batch normalization, then apply the ReLU, and then pull them. So that way my network learns in a way that is very very smooth, and you can expect the learning curve to go smoothly down, rather than jumping up and down when things are not normalized. Don't have the history here. That's what I was trying to show you. Oh yeah, here's a history of the epochs. You can see that it practically saves the model after every epoch, because it keeps learning. If you look, the training loss here is 489, validation loss 487, and here 477, 67, 55. So it learns very smoothly because it's very normalized. It goes all the way to epoch 33, and only then starts wait. It takes like a little bit of patience here, like 5 or 6 epochs to get something better and save it. And the more you train, the more epochs it takes for you to hit into another local minima that is better than the one before, and save the model. So that gives you a test accuracy of 25%, and basically if you would train with 1,000 epochs, you can start getting basically something of value. So this is what I wanted to show. I'm using dropout in the fully connected layers right here. So fully connected layers, I drop out, and then I apply fully connected, and then ReLU. I drop out again, fully connected, and ReLU. And then we get the final scores, and put it in the. So these are some ideas. If you like to train your own network, you can keep iterating over these. I'm sure there are things that you can improve, or small problems with the architecture that you can fix. The more you read, the more things you want to try. But this normally you don't use dropout in between convolutions. You just use dropout at the end. Some people have tried dropout, but very small, like 0.1%, 10% dropout or something like that in between convolutions. But that's you cannot really use much dropout here. So keep your dropout for the fully connected layers. That is where it works. Okay. I have some comments for the transfer learning part. So we have a number of different models that you can try. You have the Inception model, the VGG16, VGG19. You also have the ResNet model. They're all very high performance models, and you can try any of them. I think that either one of them will work, and essentially the process is the same. So these models have like any neural network, right? I mean, any convolutional neural network. The first part is to do the abstraction and find the structure in those pixels, and those are the convolutional layers. After a series of convolutional layers, you have a classifier at the end. It's a regular dense layer that, or a couple of dense layers. So what you are going to do is you're going to tell the model that you load the model, and then you tell, okay, for all the layers in the in the convolutional layers, the feature extraction layer, you're going to tell them, I don't require gradient. I'm just going to use these layers in a feed-forward fashion. Just I'm not going to train them. So don't compute gradient for these. Don't keep the gradients because I don't need it. And for the classifier, essentially you are going to replace it. So you are going to put your own classifier. Here is one where we use the sequential construct in PyTorch, which essentially forms the pipeline with all these layers. So the output of one is fed into the input as input in the next one. Orderdict is just a Python dictionary, fancy Python dictionary that keeps order, but keeps the order in which you put them. Otherwise, dictionaries don't have order. And the reason to use a dictionary here is just to be able to give it a name. So this is the key and this is the value in the dictionary. It's just, okay, you can give it a name to each one of the layers. But this might have some significance for debugging later on, when you show the model, just to know that this is the fully connected one, this is the rel, etc. But really, you could just have gone with a list without all the keys, and it would work the same. So once you change the classifier in the model, you will be basically you have now a model that has all the feature extraction part pre-trained and frozen, because you don't compute in gradient there, you're not going to train it, and the classifier part is blank. Essentially you have just initialized it, and at that point you start training it, and it's only going to train your classifier with your labels. So don't have much in the way of the rest of the things, and so I will have to go and show you in my notebook. So let's see what do we have here. So you probably use the same thing for for loading the images, and go and change your classifier. Let me see. Here's my classifier. I'm just using two fully connected with a 0.5 dropout, and that's giving you more or less 81 acceptable performance with a few 20 epochs. So here is the classifier, and as you see, I didn't use the ordered dig, but so what you need to know is what are the input features. The input features, you can find them in the when you print the model, probably, and when you print the model, you will find the linear features here. In this case, I already updated it, but if you put this print up here, you essentially have the same information, and you will know what is the input features of your linear, and you have to use that. Otherwise, you can just I think take it directly from the layer in a basically just put an assign here that gets the model classifier 0, and then the number of units, of input units. There, you probably can get it programmatically. So so this is mostly it. I don't have much more to discuss today. If you have some input for me, I would like to know. So there are some other number of things that can go wrong with the notebook, but in general it's a very straightforward project, and it shows you something very important, essentially the way that you would productize machine learning, the way to give you ideas of how to put it inside an actual product. And if you look at some of the extra effort that you can add to the project, you could make the effort of trying to put it in a Docker container, and then wrap it into some Python framework for creating a web backend, and then set it up on the web, so you can actually show anyone how it works. That's a project that I went through when I did this. Is very interesting, and you can use the web infrastructure that is already, the cloud infrastructure that is ready. Basically costs very little to have an actual demo of your network. So with that, I will close it for today, and please remember to book your one-on-one interviews. If you don't have availability, you can always text me and tell me a little bit more about when you have a regular time in the week when we can meet, and I will try to make that time available during my schedule. I usually don't put schedule available time slots for when I'm working at the office, but if somebody has a very difficult time connecting during the normal hours that I offer one-on-ones, we can discuss that. We can set up a special time, like a one-time basis. We'll see how it works. Okay. Thank you very much, and see you soon. So